Greetings everyone. Welcome to the session for today for mathematics, which I'll be talking about exponents and surds. I trust you are all well. Okay, let me share the video. Let me say the slide so that we start. Okay, then now I'm gonna focus on exponents and surds with the target audience to grade 10 to 12. Right. First of all, what I will actually do is I'll first explain the laws of exponents that are necessary for us to solve questions that follows, and also we're going to talk about say surds. Right, let me start with the exponents. We know, ladies and gentlemen, exponents are important when you are solving expressions, especially in algebra. Right, I'm going to start with exponents. This is also important for the grade 9s and also the grade 10s, 11s, and 12s. But in grade 9, what is actually important is just the exponents. Right, let me take you through the exponents first. I'm going to start with the exponents. Then I will end up with the surds. Right. Let's start with an exponents. Right. We know that, guys, when we are dealing with exponents, most exponents are actually written in the form of a to the power of x, where this expression as a whole, we call it an exponent. And on this expression, actually, this is called this part here, the a, it's actually called a base. We call this a base. And these x here, it's actually called an exponent. In another book, they call it an exponent, or we call it a power, or we call it an index, or an index. So what we can say, like, if we want to translate this, we can say a to the exponent of x, or a to the power of x, or a to the index of x. So now we're going to talk about the laws of exponents. Right, this is very important, ladies and gentlemen, when you are solving problems, particularly in grade 10, 11, and also 12. Right, I'm going to start with the first law of exponent, law number 1, which you call it a multiplication law, actually. Let me just write it in full. Multiplication law, which says if we have a to the exponent of x, or a raised to the power of x, you multiply this with a to the power of y, or a to the exponent of y. As long as in between we have multiplication, this is for multiplication, the law says when the base are the same, remember here our base is the a. When the base are the same, we take one base and we add the exponent. So this is according to the law of exponent that says if the bases are the same in terms of exponents, we take one base and we add the powers or the exponent. Only for multiplication. If there is multiplication in between, as long as the bases are the same, then we take one base and we add the exponent. Which means that within this law, if we have something like this, 2 to the exponent of 3, and we multiply by 2 to the exponent of 1, then as long as the bases are the same for multiplication, we take one base and we add the exponent. So this will be 3 plus 1, which is equals to 2 to the power of 4. So which will just give us 16. Is because of this law. That's why if we say, let's say we have x, we multiply this with x. So according to the law of exponent, this is an exponent. It's just an exponent because it's power 1, and this is raised to the power of 1. So which means that when the base are the same, our base is x, and our exponent or the power is 1, which means this is the same as x to the power of 1 plus 1, which is the same as x squared. That's why we know now that when you take x times x, it becomes x squared. It's because of these exponents. Very important. And in most of the cases, the multiplication can also be written in terms of brackets. So if we have something like this, we know in between there is multiplication. So which means that same applies, we can still use multiplication law that says when the base are the same, we take one base, and we add the exponents. We take one base, which is x, and we add the exponent, which will be 1 plus 1, which gives us 2. This is according to the first law of multiplication. Then now we move on to the second law of multiplication. This is very important, guys, for you to know the laws of exponents. Then the second law, it is the division law. Okay, so the second one is the division law. Okay, then the division law, I'll just write this as division law. This is the law when we're dealing with division, when we're dividing, which says a to the power of x divided by a to the power of y, or a to the exponent of x divided by a to the exponent of y. As long as it's still the same as a to the exponent of x divided by a to the exponent of y. As long as we are dealing with division, the law of exponents says when the base are the same, we take one base and we subtract the exponents, which means we're going to say x subtract y. This is the law of exponents. For division, it says you take one base and subtract exponent. Subtract the exponent or the power. So when we are dealing with division, but when you're dealing with multiplication, you take one base and you subtract the exponent. Why is that true? If let's say we have this expression, just an example. Let's say we have x raised to the power of 3 or x to the power of 3. We divide this with x to the power of 2. If we can recall from grade 8 to grade 9, x to the power of 3 is the same as x multiplied by x multiplied by x, which is the same as divided by x multiplied by x, which means you can see that if we were to take this from grade 8 and 9, this is the same as the x and the x will divide, and the x and the x will divide, and we're going to remain with x. We're going to remain with x. So x is the answer. So which means to avoid doing these expansions, we have to use the law of division, because we cannot keep on solving exponents in this format, because if we had, let's say we had x to the power of 7 divided by x to the power of 2. Let's say maybe x to the power of 10. It means we have to expand this 10 times if it's x to the power of 10. So since it's x to the power of 7, we have to expand this 7 times, which will be a tedious work. So to avoid this, then we have to know the law of division that says, as long as the base are the same for division, as long as the base are the same for division, what we do, we take one base and we subtract the exponent, which becomes 3 minus 2, which gives us x raised to the power of 1, which is just x, which is the same as that one there. So these are the most important laws when you are solving exponent. So it's very, very important to know the laws of exponents. So there are a lot and lot of examples that you can actually solve using this law of exponent. Right, moving on, we're going to move on to the law number 3. The law number 3, it says when you have A, I'll just use A here as our base. If you have A raised to the power of X and also everything raised to the power of Y. So if you hear here, if you check here, we have 2 powers actually. So we have A raised to the power of X, everything to the power of Y. So we have 2 powers there. So this law says, since we have same base, we have one base, but with multiple powers or multiple exponents or index. What we can do according to this, as long as we have multiple exponents or multiple powers, what we can do is we can just multiply those powers. We can just take one base, we can just take that base and we multiply the exponents or the powers. So this becomes a to the power of x times y, which is just xy. Why is this true? Imagine when we have this. Imagine when we have this expression here as an example. Let's say we have this expression, for example. Let's say we have x to the power of 2, everything to the power of 3. So if we want to expand this, maybe using this criteria, like the example I did here. So this will be the same as x squared multiplied by x squared multiplied by x squared, which means we will repeat x to the power of 2 3 times. Then obvious, here we remained with multiplication in between. And we know the law of multiplication says, as long as you are dealing with multiplications, that is the same base, as long as the base are the same, what we're going to do, we take one base and we add the exponent. So this will be 2 plus 2 plus 2, which gives us x to the power of 6. So to avoid repeating this or expanding the expression in this format, this law says as long as you have multiple powers with one base, you can multiply those powers together, which is the same as saying 2 multiplied by 3, which will just give us 6 without having to expand this. Because imagine if we had, let's say we had x raised to the power of 3, everything to the power of 10. Which means if we want to follow this pattern, it means we have to multiply this. We have to expand x to the power of 3 10 times. So it will be x to the power of 3 times x to the power of 3 times x to the power of 3 times x to the power of 3, just like that 10 times. Which will actually be a tedious work. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then these will be, we'll still have to use multiplication law because there is multiplication in between, which says when the base are the same, we take one base and we add all the exponents of the powers. So which will be 3 plus 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 3, 10 times, which is just be 30. which is x to the power of 30. So to avoid expanding this expression, we use law number 3 to simplify this kind of exponents. So to avoid expanding the expression in this fashion, in this way, what we do is we just look at the powers and we multiply the powers together. So which will be 3 multiplied by 10, which gives us 30. This is according to the third law of exponent. I believe you're following. I'm just expanding this to accommodate the grade 8 and also the grade 9. But particularly this is for grade 10 to 12. Let me just say specifically for grade 10 and 11. Now, which means that it's very important for you to know the laws of exponents, guys. Very important. All right. In terms of the laws of exponent, a learner who understands the laws of exponent, it's easier for him or her to expand expressions. In terms, let's say you'll be factorizing, such things, then it's easier for you when you know the laws of exponents. Then now, let's move on to the next law, which is, these are the most important one actually. I'm going to call it law number 4. So we have law number 1, number 2, division law, number 3, and number 4, which says if you have multiple bases, let's say you have A times B raised to the power of X. Here you see we have different bases. We have base A and we have base B, but all are raised to with the same power or the same exponent. So this law says if you have multiple bases but which has the same exponent of the power, you can expand them as A to the power of X multiplied by B to the power of X. Remember, I'm talking about multiple. It does not matter. It can be A, B, C, D, as long as they're raised to the power of n. So this is the same as A to the power of n, B to the power of n, C to the power of n, D to the power of n. This is according to the law number 4. This is according to the law number 4. For example, let's say we need to expand, let's say we want to expand 21 to the power of x. 21 raised to the power of x is the same as, 21 is the same as 3 multiplied by 7, everything to the power of x. So you see that here we have different bases which has the same exponent. So we can expand these as 3 to the power of x multiplied by 7 to the power of x. It's very important to know these laws, guys. It's very, 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 very important to know these laws. It is very, very important to know the laws. We'll do a lot of questions that are relating to this. So you must be able to know this law. The law, we have multiplication law, we have division law, and we have the law number 3, which says if you have one base with multiple exponents or with multiple powers, you can multiply those powers together. You don't add them, you multiply. And in most of the questions, or in most of the questions that I actually see learners, the misconceptions that actually learners do in the exam, it's, let's consider a case where we have 3 to the exponent of x plus 3 to the exponent of x. Remember, in terms of the laws that I have explained here, we do not have addition law. In terms of exponents, we have, like in terms of exponents, we have multiplication law, which says as long as you have multiplication in between, You can take one base, you take a base, or you take one base, and you add exponent. You add exponent of the powers. But look, you find that in the exam, Elena start doing this and say, okay, this is a base. I see it's a base, and this also is a base. Because of this, then I can say 3 to the exponent of x plus x, which is 3 to the exponent to x. This is wrong. It is not true. Why are we saying it's not true? This will be true if we had multiplication sign. Because of we do not have multiplication sign, you cannot say 3 to the exponent of x plus 3 to the exponent of x is the same as 3 to the power of 2x. It's wrong. It's not the same. This would be true if we had 3 to the exponent of x. If we had 3 to the exponent of x multiplied by 3 to the exponent of x, this would be true. Because we will say we have 3 to the exponent of x plus x. Because we have multiplication, we take one base and we add the exponent, and this becomes 3 to the exponent of 2x. I apologize. I hope you guys are following. I believe you're following. All right. So now these are types of laws that you need to know whenever you are dealing with exponent. So this is some misconception that I wanted to address, because most learners do this and it's wrong. It is wrong. Because now it means the answer, the correct answer here, we just have to say we have 3 to the exponent of x plus 3 to the exponent of x. These are like terms. This is the same as 2 times 3 to the exponent of x. 2 times 3 to the, it means we have 3 to the exponent of x, 2 of them. So it's 2 times 3 to the exponent of x. It's very important for you to know this. Then another, this actually, I want to talk about them. It's, okay, when we are dealing with negative exponent, how do we resolve cases where our exponent or our power is negative? Before I start talking about the surds, let me just call it law number 5, where we're dealing with negative power or negative exponents. So number 5, it says, if you have a raised to the power minus x. Now I'm talking about negative power exponents. When we're dealing with like exponents that have negative powers actually. So if the power here is actually negative, how do we deal with this? We want to change this to be positive. So to do that, this is the same as, to change this to positive, it means this is the same as 1 divided by a to the exponent of x. A to the exponent of x. That is the answer for that. So it means all the time when you are dealing with negative powers, to change them to be positive powers, they have to be in the form of a fraction. And these are some of the questions, like in the exam, you find that most learners actually is struggling to change exponents that have negative powers. So for example, it means here it's all about playing with your power. For example, if it's positive here, we can take it up. Taking it up, it means it will become negative. You bring it down, it's positive. Up, negative. So it means this is the same as saying, okay, fine. If let's say we have 4, we divide by x to the exponent of 3. Let's look at the power. The power here is 3, and it's actually positive. What if we want to make this to be negative? It means we have to take this expression to the numerator. And to do that means that the x power must change the sign. If we take it upwards to the numerator, it must change the sign. It means this will become 4x to the power of minus 3. So which means if I want to change it back, it means I will just leave the 4 and take this downwards to the denominator. So let's do example in terms of this. Let's do one example because this is very, very, very important. Let's say we have this expression. Let's say we have this expression. Okay, I'll just do one example. Let's say we have x to the power minus 7, or x to the exponent minus 7. How do we change this from having a negative power to positive power? To do that means to change it from being negative to positive means we must end up having a fraction. It means there is a 1 here. So we're going to say 1 divide by, then we take it down by what? X, then changes the sign, raised to the power of 7. So it's all up playing about like the powers actually. So it means we can still take this up and down. So it's very important to know this. I apologize. For example, if we have 2 to the exponent minus 3, it means this will be 1 divided by 2 to the exponent of 3. It's very, 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 very important to know that. This is when we are dealing with negative exponents, changing them from being negative to positive powers. Right, let's say we have another one. Let's say we have a raised to the power minus 1. So this will be the same as 1 divided by a raised to the power of 1, which is just 1 over a. But how about if we have a times b raised to the power minus 1? Sorry, I apologize. Which one it's having a negative exponent? It's the b. The a has a positive exponent. It means we do not have to change that. So it means to change this to have positive exponent means we're gonna remain with the a here, and we divide there by b raised to the power of 1, which is just the same as a divided by b. But if we had, for example, if both a and b were negative in terms of powers, let's say we had something like this. Let's say we had a to the exponent of minus 2 times b to the exponent of minus 3. Then let's say we are asked to simplify this to have to remain with exponents that have positive powers. What could be the answer? I'm going to give you 2 minutes to just try to solve this, and we'll do the corrections. What would be the answer? So it means now we're going to say, okay, just finish up. Okay, I believe you are done. Now, let us do the corrections. Look, I said whenever we are changing the exponents, that is negative powers to have positive powers. It means if they're at the numerator, those exponents or there's to be at the denominator. So now this will be the answer. Because both A and B are both negative, have negative powers. It means to change them means we're gonna do this. We're gonna remain with at the numerator because there's a 1 here, and both then means we're gonna have 1 divided by A to the exponent of 2. We've changed that one for A, and also B to the exponent of 3. So this will be the answer. Same applies. Even if we wanted we want them to have to go at the numerator, it means they will have to change. The sign of the powers has to change. You see, it will be A raised to the power -2 and B raised to the power -3. Then we're going to remain with this. So it's all about playing with the powers actually. It's very important. It's very, very, very important. Now, how about if we had this? Let's say we have, let's say we have x squared, y raised to the power -7 divided by, let's say, w to the power of -3. And we want to change, we want to simplify this to remain with positive exponents. So you see that here already, x to the power of 2 already has a positive exponent, it's fine. But look at the y. The y has a negative power, which means we have to change it to be positive. It means we have to take it down to the denominator. And since we are taking y raised to the power -7 down, so that it changes, its powers becomes positive, it means we also have to change that one for w. So it means the w has to go to the numerator. So it means the answer will be x squared, y raised to the power of 3, y raised to the power of 3, divide by, I'm saying, yes, no, I'm saying it's x squared, y to the power of 3, and I'm saying w to the power of 3 divided by y to the power of 7. So this is the answer. We changed everything to have positive powers. I believe you are following. I believe you are following. Then with this, then we also have the other, this one is not actually a law, it's just a deduction to say any number raised to the power of 0, it's always equals to 1. Any number raised to the power of 0, it's always equals to 1. And why is this true, that any number raised to the power of 0 or any number to the exponent of 0, it's always 1? Let's look on this example here. Let us look on this example. Let's say we have x to the power of 2 divided by x to the power of 2. If we were to expand this in terms of exponents, this will be x multiplied by x, this grade 8 work, divided by x multiplied by x. So the x and the x will divide, and the x and the x will divide with 1. Let's look at this. If we were to simplify this, because we know that x squared divided by x squared is 1, let us use the law, the division law, because we are dividing here. So the division law says, since we are dividing, we take one base and we subtract the exponent. This will give us x to the power of 0. And you see that since we have x to the power of 0, it means these two things are equal because x squared divided by x squared is the same as this. And since this one is 1, it means even x to the power of 0, it's 1. Which means any number raised to the power of 0, it's always equals to 1. And guys, this is very, very important for you to know. So before we go through the questions, I want us to actually remind ourselves, or let me just summarize what I said according to this, so that you actually know what you are doing. So it's very important for you to go through all these laws of exponents. The multiplication law, the division law, the law number 3, which says when you have one base, but with multiple powers, you can actually multiply those powers. Then the law number 4 says if you have multiple bases that has the same power, then you can just expand them. You expand those bases with those powers. So to summarize, number 1, a raised to the power of x multiplied by a raised to the power of y. For multiplication, take one base and add the exponents. Number 2, a raised to the power of y divided by a raised to the power of, a raised to the power of x divided by 8 raised to the power of y. For division, when the bases are the same, you take one base and you subtract. Law number 3, it says when you have a to the exponent of, to the power of x, everything to the power of y. As long as you have multiple powers with one base, you can just multiply those powers. Number 4, it says when you have a multiplied by b, everything to the power of x. This is the same as a to the power of x multiplied by b to the power of x. Number 5, it says when we have a to the power of minus x, to change the exponent that is a negative power, you're always going to have a fraction. So it's going to be 1 divided by a to the power of x. I hope you understand. So we're changing this, we're taking it to the denominator. So this is what we're going to have. Then we also have the deduction that says any number to the power of 0 is always equals to 1. Any number raised to the power of 0, it's always equals to 1. So you need to know these laws when we are solving questions. Very important. So we'll be using this law, even though you do not know them according to, like in that order, but as long as you know all these laws, then you're good to go. And another thing, when you are dealing with exponent, you must be able to simplify fractions. Simplifications of fraction is very important. You must be able to simplify fractions, ladies and gentlemen. For example, remember in the lower grade, I think from grade 5, grade 6, they taught you how to simplify fractions. For example, if we have 1 over 2 plus, like, let's say 1 over 3. We know when we simplify fraction, like back then you have to determine the LCD, the lowest common denominator. But to avoid doing this, what we're going to do is we're going to just use a short method to say, we always look at the denominator. We multiply what is at the denominator. So 2 multiplied by 3 gives us 6. Then after multiplying the denominator, what we do, we cross multiply, we apply cross multiplication. So this will be, first we multiply 1 with 3. So 1 multiplied by 3, this will be 3. Then we also multiply this. Plus 2 multiplied by 1 is 2. So it means the answer becomes 5 over 6. I believe you're following what I've done. Which means we, instead of writing this, we can change this and say, okay, what if we have x over y plus, 1 over x. And we're asked to simplify this fraction. It's still a fraction. So how to simplify that? We do exactly as what I've done here. We multiply the denominators together. And since the two are unlike terms, what is x multiplied by y? It will just become xy or yx, but let's just write xy. So I've multiplied the denominators. Then after doing that, I have to cross multiply. I'll start with this one. This is the first one. X multiplied by x, this gives us x squared. Why is it x squared? The law of exponent multiplication. Because x multiplied by x, the base are the same. We take one base and we add the exponent. This becomes x squared. Then now, secondly, we multiply this. Y times 1, it becomes y, but there's a plus y. Then this becomes x squared plus y all over xy. This is how we simplify fractions. This is very important, guys. It's very, very, very important. Now, before I start talking about, let's just also talk about the law of like the surds, so that when we will start solving the equations, then I will not be talking about the laws of exponents. I'll just apply them now. Okay, I believe you guys are following. I'm actually doing this to also accommodate learners who are in grade 9, like in terms of how to simplify fractions. Also in the lower grades, that's fine. Right, then now, let's talk about the surds. Because now I was talking about the law of exponents, then now I want to talk about surds. But the surds, guys, this is for actually, it's relevant for the grade 10s, grade 11s, and grade 12. But even in grade 9, there's also surds. Right, let me talk about surds actually. Surds. Which in other book they call them the radical expressions. Right, when we are dealing with surd or radical expression, are those expressions that are in the form like in a root sign. It's where we're dealing with the root sign. Expressions that are in radicals, we call them surds. For example, the root of a. This is called the root, the root of a. So expressions that are in radical form, we call them the surds. So we want to talk about the laws of actually surds. Now, let me talk about the law of surds. Number 1, it says the root of any number, the square root of any number, the root of a, it's always equals to a raised to the power 1 over 2. So the root of a, it's always equals to a raised to the power of half. This is very important. So what does this mean? It means when we are given a radical, for example, if we have, let's say, the square root of 2, if we want to change this into exponent, this will be 2 to the exponent of half. This is according to this surd law. So it says when we have the root of a, this always equals to a to the power 1 over 2. And the second one says, if we have the nth root of a, the nth root of a, this is called the nth root. This is the nth root of a. So the nth root of a, it's a raised to the power 1 over n. And these two are actually related. So it means that when we say the nth root of a, it's a to the power 1 over n. Where there is a square root sign, actually, if we say the root of 2, I mean the root of a, it means here, actually, we can say the n here is actually 2. Because if we substitute here by 2 and there by 2, then this becomes the root of a, it's 1 over 2. So it means wherever there is a root sign, you must know there's a 2 here. So it means that the nth root, the square root of a is a to the power of 2. But how about the nth root? The nth root will be a to the power 1 over n. For example, the cubic root, I apologize, the cubic root of x. The cubic root of x. This will be x raised to the power 1 over 3. Why? Because the n is 3. The fifth root of k, this will be k to the exponent 1 over 5. This according to this. Then another one, number 3, let me use the same color. Number 3, in terms of the surds, it says, number 3, if we have the root of a times b, the root of a multiplied by b is the same as the root of a multiplied by the root of b. So the root of a times b is the same as the root of a alone multiplied by the root of b alone. So the root of a times b is the same as the root of a multiplied by the root of b. So it means that even if we have, it's not about this only, even if we have a division, let's say we have a divided by b. So this will still be the root of a alone divided by the root of b alone. So it's very important to know this. So even if we have the nth root of a times b, this will still be the nth root of a multiplied by the nth root of b. So we can still split this. And this, guys, this is very important, especially when we are dealing with surds. Also in grade 12, because especially when we are solving, like when we are dealing with derivative, when we are differentiating expressions in calculus, those one in grade 12. There are some times where you find that you are given radicals or surds expressions. So you need to know these laws. So the root of a number is that number to the power of half. And the nth root of a is just the a raised to the power of 1 over n. And the root of a times b is the same as root of a alone multiplied by the root of b, whether you are multiplying or dividing. But it's not true when you add or subtract. For example, you cannot say, for example, if you have the root of a plus b, the root of a plus b is not the same as the root of a plus the root of b. It's not the same thing. Because if you say, let's say you have the root of 2 plus 4. Let's say, okay, let's say the root of, yeah, 2 plus 4, it's fine. So the root of 4, you cannot say is the root of 2 plus the root of 4. Because if we were to work this from your calculator, so sorry, the root of 2 plus 4 will give us root 6. This will be root 6. And what is root 6 in decimal? It will be around 2.5. But let's work out that one on the right hand side. The root of 2 alone plus the root of 4. This will give us 3.4 And you see that 2.5 and 3.44 are not the same. So it's not true for addition and also for subtraction. You can't say that when there is addition or subtraction. It's not true. It is not true. So these are very, very, very important, especially when you are dealing with expressions that are involving surds. That's why if we do this, let's say we want to know now, okay, fine. Without using a calculator, let's say we want to know, okay, fine. If you want to know that, okay, fine, when we take the square root of 2 and we multiply with the square root of 2, the square root of 2 multiplied by the square root of 2, what would be the answer here? We can do it like this, okay, fine. Square root of 2 multiplied by the square root of 2 is the same as square root of 2 times 2. Why? Because of this. Isn't we know that the square root of a times b is the same as the square root of a alone multiplied by the square root of b alone. So it means if we have this, we can reverse the expression back to that one. And in that case, we can say, okay, fine. Because we know that the square root of 2 multiplied by square root of 2 is the square root of 2 times 2, using this law, 3, then this will be the root of 2 by 2 becomes 4. And what is the square root of 4? If we don't want to actually use like calculator, this will be 4 is the same as 2 to the exponent of 2. Because I can even use the multiplication law. 2 to the power of 1 times 2, so it's 2 to the power of 2. But I know the root of any number is that number to the power of half. So you see that here, I can use law 3 because I have multiple powers. I have power 2 and I have power 1, half. So it means I can multiply that. 2 to the exponent of 2 times half. And what is 2 times half? This becomes 1. So it means the final answer becomes 2. So that's why we know that the root of 2 times the root of 2 is the same as 2. And this is not the only approach. Another way we can say, let's change the root of 2 using this rule. We know that the square root of any number is that number the power of half, times the square root of any number is that number the power of half. Now, since we converted these to exponents of multiplication, now we know in terms of multiplication, when we're multiplying expressions that have the same base, we take one base and we add the exponent. So it's going to be half plus half. And what is half plus half? It's 1. So that's why it gives us 2. So it's very, very, very important to know these laws of exponents. I believe you are following. So now let's take this further. Let's take this further into the examples. So like we are going to solve questions and on like that involves the use of exponents and surds. I believe you're following. I believe you're following. Okay. Right. Let me erase here. Just a minute, guys. Okay. Now let's move on to the questions. Okay, yeah, the question, we'll start with question 1. Question 1 says, evaluate the following indicial expression, the indices actually, giving the final answer as an exact simplified fraction. So it means we have to give the answer as a simplified fraction. So now, what are we going to do here? We're going to simplify. We have 4 raised to the power of 3 over 2 plus 4 raised to the power minus half. Then what we can do, we know in between, yes, this 4 is a base, but there's multiplication. So we cannot use multiplication law. So what we can do, we can change 4 to have a base of 2. How? Because 4 is the same as 2 times 2, which is 2 squared. Which means wherever there is 4, we can say, okay, this is 2 to the power of 2, everything to the power of 3 over 2. So I've expanded 4 to have a base of 2, plus into, then 4 is the same as 2 to the exponent of 2, everything to the power minus half. I believe you are following. Especially in most of the cases, expressions like 4, the perfect square numbers, 4, 16, 81, 49. So you must be able to know, for example, this is 2 to the exponent of 2, this is 2 to the exponent of 4, or 4 squared. Even you say 4 to the power of 2, but you still have to expand it. Then this is 3 to the exponent of 4, or we can say 9 to the exponent of 2. Because 9 to the exponent of 2, it's 81. But 9 is this is the same as 9 by 9, but 9 alone is 3 to the exponent of 2 by 3 to the exponent of 2. You see that the base are the same, so it's 3 to the exponent of 4. So 49, we have 7 to the power exponent of 2. So it's very important to know that. Right, I want us to simplify here. What have we done here? We just expanded, we changed the 4 to have a base of 2. Remember, we cannot use multiplication rule because in between there's addition. So from here, what are we going to do, guys? Look on the first term. On the first term, we have a base, our base is 2. But we have multiple powers. We have power of 2 and we have power of 3 over 2. Same applies, power of 2 here and power of minus half. So we're going to use law number 3 that says if you have a to the exponent of x, everything to the exponent of y, we can multiply the powers. So it means this will be 2 to the exponent of, let me just use the same color. So we're still going to have, we have 1 base 2 to the exponent of 2 times 3 over 2. I'm multiplying the powers plus 2 to the exponent of 2 multiplied by minus half. You see, I'm using this law. Okay? So now when we simplify this will be 2 to the exponents. What is 2 multiplied by 3 over 2? It will just give us 3. Plus, then same applies, 2 multiplied by negative half. This will give us 2 to the exponent minus 1. Remember, they said we want to simplify this. We have to expand this to a simplified fraction. And what did I say? We have a negative exponent here. We have an exponent that is a negative power. How do you do that? We can change it to have positive power by taking it to the denominator, because already it's not a fraction. So it means this will be 2 to the exponent of 3 plus, we change this. This will be 1 divided by 2 to the exponent of 1. So we've changed this as being negative to positive. So simplifying this will be 2 to the exponent of 3 is the same as 8 plus 1 over 2. We need to simplify this without using a calculator, or you can also use a calculator, but what you cannot do, it's okay, fine. This is 1 over 2, it's a fraction, so it means you can divide there by 1. I think I've shown you how to simplify fraction. Let us simplify fraction. We can multiply the denominators. I think I've said that. Let's multiply the denominators first. Okay? This will give us first one. second one. Okay, 1 multiplied by 2, we are multiplying the denominator first. 1 multiplied by 2, then the answer becomes 2. Then we cross multiply. 8 multiplied by 2, it's 16. And 1 multiplied by 1 is 1. So the final answer is giving us 17 over 2. So this is the answer. So let's check what have we done here. We expanded 4 to have a base of 2. And after expanding 4 to have a base of 2, we used law number 3 that says when we have multiple x powers, you can multiply their powers if the base is the same. So we multiplied 2 with 3 over 2, and we multiplied 2 with minus half. This gave us 3, and this gave us minus 1. Then we changed the negative exponent to have a positive power. So this becomes 1 over 2. Then we simplified. I believe you are following. Then let us look on the second one. Let us look on the second one. The second one says, simplify fully the following expression. Here we have 12 y to the exponent minus 5 divide by 3 y to the exponent of 2, negative 2, I apologize. So now we're going to do this. We're going to say, okay, fine. Let's check. Here, there's a multiplication in between, but also have a division. So we're going to do this, okay, fine. 12 and 3 are just numbers. So what we're going to do is we can look for a number that goes into 12 and also into 3. Or another way, we'll say, okay, we know 12 is 4 multiplied by 3. Y to the exponent minus 5 divided by 3y to the exponent minus 2. So you see that the 3 and the 3 will actually divide. So we're going to divide there by 3 and divide there by 3. So it means we're going to remain with 4 y to the exponent minus 5 divided by y to the exponent minus 2. But if you look at this, these two, without having to look at 4, we have division. We have division. So if I can, let's say, let me try to separate it. So you see that we have y there and also have y. And they have the same base, and here we have division. So we know the law of division. It says, for division, if the base are the same, what you do, you take one base and you subtract the exponent. So it means this will be, in terms of, this would be 4. Remember, we are taking one base. Okay, like, yes, we're going to eat the 4, we just leave 4. Then here we are going to take one base and say, okay, we have one base, which is y, and we subtract the exponent. What is the exponent at the numerator? It's negative 5. So it's going to be negative 5 minus, we are subtracting, into negative 2. So we take one base and we subtract the exponent. So this will be 4. Okay, let me try to raise here. This will give us 4 y to the exponent minus 5 plus 3. I'm saying plus 2. I apologize. Because negative into negative 2, this gives us positive 2. And what will be the final answer? The final answer will be y equals to y 4 multiplied by y to the power minus 3. But we do not want to remain with negative exponent. I'm saying negative power. So this will be, yes, 4, we bring it down, divided by y to the exponent of 3. So this will be the answer. I believe you are following. I believe you are following. Okay. Right, let's move on. Okay, just a minute, guys. All right, let's move on to the next question. The next question, yes, evaluate the following expressions giving the final answer as in a simplified form. I believe now you're following. I'll try to be fast because you understand now. So it means this will be the same as 2 to the exponent minus 4 plus a to the exponent minus 1. We can do this in two ways. We can change everything to have a positive exponent. This is the same as 1 to the power 1 divided by 2 to the power 4 plus 1 divided by 8. And this becomes 1 over 16, because 2 to the power 4 is 16. 1 over 16. Then plus 1 over 8. And now, to simplify this, let us look at the denominator. Remember, we can do this in two ways. There's no problem. We can just follow the route that I've said earlier, without. So we can multiply here. Let's multiply here. 16 multiplied by 8. This will give us 128. Then we cross multiply there. So this gives us 1 times 8 is 8 plus, and we cross multiply there. This gives us 16. And what is 8 plus 16? 8 plus 16 gives us 24. So it means it will give us 24 divided by 128. And we can now look for a number that goes into 24 and 128. I believe that number would be okay, let's check. Okay, that number would be 8. Yes, that number would be 8. Because 24 divided by 8, it's 3. So it means 8 goes into 24 3 times, and into 128 it goes 16 times. 16 times, so the answer becomes 3 over 16. Or another way would be if we had 1 over 16 here, plus 1 over 8. Since here we have like the highest denominator is 16, so we can say this can become 16 if we multiply it by 2 and by by 2 both sides. So it means it's going to be 1 over 16 plus 2 over 16, and this gives us 3 over 16. This is the answer. Another way would be we can have this and say, but still, but still we'll get the same answer, because we're going to have 2 to the exponent minus 4 plus, we'll still have the same answer. Even if we change 8 to have a base of 2. So this will be 2 to the exponent of 3, everything to the power of minus 1. So then we're going to have 2 to the exponent minus 4. Then we multiply this because it's multiple powers, we can multiply them. This gives us 2 to the exponent minus 3. Then we change this to have positive exponent. So it's 1 over 2 to the exponent of 4 plus 1 over 2 to the exponent of 3. So this will still be 1 over 16 plus 1 over 8. You see, we still get the same answer. Okay, I believe we are following. Let's move on. Okay. Okay, then now the second one says 81 divided by 16. 81 divided by 16 raised to the power 3 over 4. So we have 81. Okay, let me use a different color. 81 divided by 16, everything to the power of 3 over 4. Right, how can we simplify this? We can simplify this in two ways. we can say, since we have a over b to the power of n, this is the same as a to the power of n divided by b to the power of n. So we're going to say we have 81 everything to the power 3 over 4 divided by 16 everything to the power 3 over 4. But we can expand 81 to have a base of 3 because 81 is the same as 3 to the exponent of 4. So which means this is the same as 3 to the exponent of 4, everything to the power 3 to the exponent of 4. I'm saying 3 divided by 4. Divide by 16. 16 is the same as 4 squared, which is the same as 2 to the power 4. So we can say this is 2 to the exponent of 4, everything to the power 3 over 4. Then now here we're going to use the rule of multiplying the powers because we have multiple powers. So this is the same as 3 to the exponent 4 times 3 over 4. Same applies, 2 to the exponent 4 multiplied by 3 over 4. So now this will give us 4 multiplied by 3 to the power 4, it will still give us 3. So it's 3 to the exponent of 3 over, this will give us, if we multiply these two, it will give us 2 to the exponent of 3. And the final answer, 3 to the exponent of 3, since the bases are not the same, 3 to the exponent of 3 is 27. And 2 to the exponent of 3, it's 8. So it means that our final answer is 27 over 8. To the power of 8. I believe you're following. I believe you're following. Okay? Then the next one. The next one, it says simplify fully the following expression. We need to simplify this expression. Okay, let's check this. If we go through this, at the numerator, what do we have? We have 4x y squared, everything to the power of 2. Divide by 2x cubic, everything, 2x, I mean to say, 2x, everything to the power of 3. So what we can do here is to simplify. We learned about the laws of exponent. And one law of exponent that we dealt with is that one of saying, if you have multiple bases, like when we have a to the power of n to the power of a times b to the power of n, this is the same as a to the power of n, b to the power of n, even if it's more than 2. So it means we can expand this as, you see, we have the 4x y squared. These are actually like there will be bases if we are relating to x squared there. So we can simplify this as saying, okay, this is the same as 4 to the power of 2 times x to the power of 2 times y squared to the power of 2. I believe you understand that. Divide by, same applies here because you have two bases that are raised to the power of the same power. So this is the same as 2 to the power of 3 multiplied by x to the power of 3. I believe you are following. But I said we can expand 4 as 2 to the power of 2. Obviously, this to the power of 2 there. Times x to the power of 2 times y to the power. Remember, we have multiple powers. There's a 2 and there's a 2 there. We can multiply them. This gives us 4. Divide by 2 to the exponent of 3 multiplied by x to the exponent of 3. And we can simplify this as, okay, we can multiply these powers here. So this is the same as 2 to the exponent of 4 multiplied by x squared multiplied by y to the exponent of 4 divide by 2 to the exponent of 3 multiplied by x to the power of 3. Then now, what we're going to do here, we're going to use, okay, since we have division, we're going to use division law considering bases that are the same. And we know in terms of exponents, if the base are the same for division, what do? We take one base and we subtract the exponents. So you see now, I'm going to try to separate them like this. To say, okay, fine. Here we have the same base, 2 and 2 are the same base, x and x are the same base. What do? We take one base, we're going to start with the first base of 2. So we're going to take one base of 2 and we subtract the exponents. This will be 4 minus 3 multiplied by, now we are moving on to x. Now the base is the same. We take one base and we subtract the exponent, taking the numerator and subtract the denominator. So it's 2 minus 3. But still, this one will not change. It will just be y to the exponent of 4. So what will be the final answer? The final answer will still be, okay, we're going to have 2 to the power of 1, okay? X raised to the power minus 1, okay? Multiplied by y to the exponent of 4, if I'm not mistaken. If I'm not mistaken. So now, what will be the final answer, guys? Remember, we want to leave our answer with positive exponents. So it means now, what's going to happen? We need to change the expression which has a negative power. If it's at the numerator, there has to be at the denominator. So it means what is going to remain here? At the numerator, we're going to remain with 2. Together with what? Y to the exponent of 4. Then we bring the one we need to change at the denominator. So this will be x. So it means the final answer is 2y to the exponent of 4 divided by x, if I'm not mistaken. So it means without having to do this, we can say in future, when we have this 4x, y square, y everything to the power, okay, so I apologize. So we can say if we have 4xy squared, everything to the power of 2, divided by 2x everything to the power of 3. Oh, sorry, everything to the power of 3. To the power of 3. To avoid expanding this expression in case, okay, 4 is a power of 1, x is a power of 1. So what we can do is we can just multiply in this 1 by 1. So it means this will be 4 raised to the power 1 times 2 times x raised to the power 1 times 2 times y to the y squared to the power 2 times 2. Divide by, same applies here, power 1, then we multiply in here. So this will be 2 raised to the power of 1 times 3 times x raised to the power 1 times 3. So this will actually give us 4 squared x squared y to the 4 divided by 2 to the exponent of 3 multiplied by x to the power of 3. If we do not want to use exponents, we can say 4 squared is the same as 16 x squared y to the 4 over 8 to the power of 3, it's 8. Then x to the power of 3. You can see that there's a number that goes into 16 and 8. It's 8. 8 goes into 8 once. 8 into 16 goes twice. So it means you're going to remain with 2x squared y to the power 4 everything divided by x. So we have to transpose this. Oh, by the way, we have to use division law for x. So this will become 2. Remember, for division, we take one base and subtract. So it's 2 minus 3 multiplied by y to the exponent of 4. So this will give us 2x to the exponent of minus 1, y to the power of 4. So you have to change that one like what I've done here. So this will give us 2y to the exponent of 4 divided by x, exponent of 1. So it's still the same thing. Still the same thing. So you need to be able to know these laws, guys. Okay? I believe you're following. There are many ways to skin a cat. Practice makes perfect. If you practice as many questions as possible, you will master exponents and surds. I believe you're following. I believe you're following. I believe you're following. I believe you're following. Okay, let's move on, guys. Let's move on to the next question. Okay. The next one, I think this one I'll leave you, I'll leave them for you to do them on your own. I will leave them for you to try to do this on your own. Same applies with this. Yeah, I'll leave them for you to do them on your own. Because this one is much related to what I was talking about. No. Okay, but let's try this one together. Let's try this one together. But anyway, let me just leave it for you guys to do it, so that we look on other questions, because it's much related to what I just explained now. Same applies with this. Yeah, let us look at number B. Number B, guys. Number B, what do we have? It says simplify fully the following expression. Remember, on the previous, you can just pause the video and try to solve this on your own, right? Okay, then now let us look at number B. Number B, it says we have x to the power 5/2 multiplied by the root of x. So you see now, this is a surd. It's a radical expression, so it's a surd expression. And how do we deal with this? I think I spoke about it, to say whenever you have the root of any expression, that expression is the same as a to the power of half. So it means we're going to change this to say this is x to the power 5/2 multiplied by x to the power of half. So I've changed a surd to an exponential form. And now, since in between there is multiplication, and our base is both its x, we can use multiplication law. And what does the multiplication law say? Whenever you're dealing with multiplication, as long as the base is the same, you take one base and you add the exponent. So it's 5/2 plus 1/2. So 5/2 plus 1/2, this is the same as 3. Why 3? 5/2 plus 1/2. The denominator is the same. Take 1 and we add the powers. I would say the numerator. So it's 5 plus 1, which is 6, which is still 3. Same applies with what I said. 2 times 2 is 4. Then you cross multiply that. This will give you 10. And that will give you 2. Then it's 12 over 4, which is still going to give us 3. So this is the answer. We've simplified the expression. So you see that we use the surds to solve this equation. The square root of any number is that number to the power of half. It's very important, guys, to be able to understand this. Okay, let's move on, ladies and gentlemen. Let's move on to the next question. Yes, here we have another one. This one says, simplify fully the following, it's question 5. Simplify fully the following expression. We need to simplify this expression fully. Let's start with the first one. The first one, it says 2 times p times q squared, everything to the power of 4. What comes in your mind? Multiple bases that have the same power. A multiplied by b to the power of n is the same as a to the power of n times b to the power of n. So if you want to show these steps fully, this will be 2 to the exponent of 4 yes, times p to the exponent of 4 times q squared to the exponent of 4. Because it's there to the power, times 5p, there's a power, it's not the root, times, look here, we have the root of q to the exponent of 6. What did I say? The square root of any number is that number or expression to the power of half. So which means this will be p, I'm saying q, I apologize, q to the exponent of 6. Everything to the power of half because of this root sign. I believe you are following. I believe we are following. So we are using, here we are using the case of the surd and the case of the the bases, that exponents that have multiple bases with the same power. But now we're gonna use that one in some instances. Well, that one that says if you have a to the power of x, everything to the power of y. And this is very important. You multiply these two. Okay, fine. This is fine because there's a 1 here, there was a 1 here, there's a 2. So we multiply this. So what is 2 to the exponent of 4? So we can just leave it because we don't have any other, we can just leave it as 16. Yeah, 16. P to the exponent of 4 times q, now we're going to multiply 2 with 4. 2 times 5, 4, because these are multiple powers. 2 times 4 gives us 8. Times 5, p times, okay, let me just, it's whether I'm using dot or cross, okay, that's fine. Then let's multiply these two. What is 6 multiplied by half? It gives us 3. And now look at these guys. We need to finalize this because in between here we have multiplication, even this one is multiplication, even that one is multiplication. Let me check. PQ, okay, fine. So what we're gonna do, we're gonna apply multiplication law for bases that are the same. First of all, what is 16 times 5? 16 times 5 will give us 80. And now let's apply multiplication law on both these two. So you look, multiplication, isn't it everything's multiplication? Then the base are the same for P. What do? We take one base and we add. So it's going to be 4 plus 1 times Q. For Q, the base are the same. We take one base and we add. So it's going to be 8 plus 3, if I'm not mistaken. And this gives us 80 p to the exponent of 5, q to the exponent of 11. So this is the answer. Because if we don't use this approach, it means someone has to expand this expression almost 4 times, and it's just a waste of time. Imagine writing 2pq squared times 2pq 4 times. It's going to be a tedious work. So here we use radical, we change the radical to exponents, because the square root of any expression is that expression to the power of half. I believe we are following. To the power of 4, p to the power of 4, q to the power of 8, 5, p, q to the power of 3. Then the base are the same. We add for q, even for p. Then 16 times 5 gives us 80. So that is the answer. Okay, I believe you are following. Let's move on to the next one. The root of 9, x to the power of 6 y to the power of 4, divided by 3x to the power of 2, y to the power of 2, everything to the power of 2, y to the power of 3, everything to the power of 2. So we can do this in two ways, guys. Let's do this. This will be, you can even pause the video, try to solve it, then you check the answer. So it's 9 x to the power of 6, y to the power of 4, everything divided by, divide by 3x squared y cubic to the power of 2. We can do this in multiple ways. Now, first of all, we can get rid of the radical sign because it's just a root. It's just everything inside, everything to the power of half. So this will be 9 x to the power of 6, y to the power of 4, everything to the power of half. I believe you're following. Divide by. So here it's multiple base that are raised to the same base. So what we say to the same power is the same as say, okay, this one has a power of 1, 3 to the exponent of 1, power of 2, power of 3. So what you're going to do, you're going to multiply inside there, 1 by 1. 1 by 1. I believe you're following, to avoid expanding it. So what will be the answer? This would be 3 to the exponent 1 times 2 times x to the exponent 2 times 2 times y to the exponent of 3 times 2. So we are multiplying by 2. And now, the same way we did in this expression, since now it's everything the power of half, it means here we have to also multiply by 2, by half throughout. So this will be, I believe you guys are following. You see that this law is very important, this one, that say a to the power of x, everything to the power of y, you multiply the powers, very important. So this is the same as 9, oh, sorry. So it means we're gonna take half multiplied by 1, multiplied by 6, the powers multiplied by 4. So let's solve, guys, let's solve. So this will give us 9 to the exponent of half, 9 to the exponent of 1 times half, times x to the power of 6 multiplied by half, times y to the exponent of 4 multiplied by half. Everything, let's now simplify the denominator, 3 to the power of 2, because 1 times 2, it's 2, x to the power of 4, and y to the exponent of 6. So let us simplify, guys. I'm trying to show all the steps so to accommodate everyone. So this will give us 1 multiplied by half. This will just give us 9 to the power of half times 6 multiplied by half is 3. 4 multiplied by half is 2. Half of 4 is 2. Divide by, what is 3 squared? We can actually do this in two ways. We can either, because already we have a base of 9, we can say 3 squared, it's 9, times x to the exponent of 4 multiplied by y to the exponent of 6. I believe you're following. So here we can use division law, looking at the base of 9, look at the base of x, looking at the base of y. We know in terms of exponent, when the base is the same, we take one base and we subtract the exponent, so it's going to be half. Remember, there's a 1 here, minus 1 times x to the exponent of 3 minus 4 times y to the exponent 2 minus 6. Let's work this out. To work this out, this will give us 9 to the exponent. What is 9 to the exponent? Oh, sorry, 9 to the exponent. What is half minus 1? It's minus half. Times 3 minus 4, it's minus 1. And 2 minus 6, it's minus 4. You see that we have negative expressions that have negative powers. But before we do this, let's expand 9. 9 is the same as 3 squared. So it means you can say this is the same as 3 squared, everything to the power minus half, x to the power minus 1, y to the power minus 4. Now we can multiply 2 with minus half. What is 2 multiplied by half? It's 1. So you're going to have minus 1 times x to the power minus x minus 1 and y to the power minus 1. All the expressions have negative exponent. So we have to change them. How to change them? Take them to the denominator. So we're going to remain with 1 here. 1 divided by. If we change this down, this will be 3 to the exponent of 1. The other one will be x to the exponent of 1, then y to the exponent of 4. So it means the final answer will be 1 over 3x to the exponent of 4. I believe you guys are following. Okay, let me check something. Okay. And another way, you see that what I've done here, I've changed, I said 3 to the power of 9, I changed it to 9. So you can still expand this 9 to 3 squared here without having to follow this. The answer will still be the same. And remember, this is not the only way of solving this question. Another way we can still apply surds, particularly on the numerator, because there are many ways to skin a cat, which means there are many ways of solving questions, especially like in maths. So now, if you look on this question here, guys, we can still expand this to say, okay, if we do not want to change that root sign, we can say, okay, fine. We know the root of AB is the square root of A alone times square root of B alone. We can still use it there. Say, okay, that this is the same square root of 9 alone, square root of x to the power 4 alone, and square root of x to the power 6 alone, and y to the power 4 alone. So still expanding. This is 3 squared. This one is to be fine. This is x to the power 4. You understand that? This will be x to the power 6. So we can change it one by one here. To say the square root of a number is that number to the power of half. So it's 9 to the power of half. It's x to the power of 6 to the power of half. It's y to the power of 4 to the power of half. It's one the same thing. So this becomes 3 squared, x to the power of 4, x to the power of 6. Let me say y, no, not x. Then we change 9 to have 3 squared is 3 squared, everything to the power of half. We multiply 6 with half, this will give us 3. We multiply 4 with half, this gives us 2. Everything to the power 3 to the power of 2 with x to the power of 4 and y to the power of 6. So we multiply the 2. This will be 3 to the exponent of 1, x to the exponent of 3, y to the exponent of 2 over 3 to the exponent of 2, x to the power of 1, or x to the power of 4, and y to the power of 6. Then we change everything to like using division law. The answer will still be the same. The answer will still be the same. Okay, I believe you guys are following. Okay, then the next one. So I'll leave you to do this, even this one. But you must be careful here, especially on question 6. You cannot multiply this inside by this. You cannot multiply the powers if there's a addition here. We do that only when there is multiplication. So what does it mean? It means you must first simplify the denominator first. I'm saying you must simplify this expression inside. So you must simplify this expression inside. So it means first what you have to do is you need to first expand 36. 36 is the same as 6 squared. And since you have the 36 to the exponent of half, so this will be 6 squared to the exponent of half. And you multiply the powers. 2 times half, it's 1, so it's 6. Then same applies, 16 to the exponent 1 over 4. You change 16 to the base of 2, 16 is the same as 2 to the power 4. But still there is 1 over 4 there. And you multiply these two then now. If you form multiplied by 1 over 4, it will just give me 1. So the answer is 2. So you see this will be 6 plus 2 to the exponent to the power 2 over 3. And what is 6 plus 2? It's 8. So we're going to have 8 to the exponent minus 2 over 3. Then you can change 8 to have to base of 2. So it's 2 to the exponent of 3. But still there is minus 2 over 3 there. And since you have a power with another power, you have to multiply them. So it's going to give you 3 multiplied by minus 2 over 3. To just give you minus 2. Then you change this to have positive power, which is just 1 over 2 squared. And which is just 1 over 4. I believe you are following there. I believe you are following. I strongly believe you are following, guys. Okay, now let's move on without wasting time. Let us move on. Okay, question. Yeah, then how about this one? Obviously, we can do this in two ways. We can say there are many ways to solve this problem. Since we have a radical sign, we can first get rid of the radical sign. So this will be 3a to the exponent of 3. You see there. Before we get rid of the radical sign, let's first simplify expression which are inside the radical, because I'm seeing something there. So what we can do, let's just write the radical sign and simplify whatever is inside. Look here. In between here, there's multiplication here throughout. So it means at the numerator, we can use multiplication law. What we can do, we can say, okay, 3 multiplied by 6 is actually 18. Then look at this, a to the power of 3 with a to the power of 2. Since everything is multiplication, we can use multiplication law to say the base are the same. We take one base and we add. So what is the base? The base is a. To add will give us 3 plus 2 times. Let's look at the b. The base there is b, and b, everything is multiplication to the power of 1. Now the base is the same. What do you do? Take one base and we add the exponent. So it's 1 plus 2, which is actually 3. Times, same applies with c. C there and c there. Same base. We take one base and we add. So this will be 1 plus 3. So the denominator, what do we have? We have 2ab c to the exponent of 4. So what we can do, just write one radical sign. Then we start simplifying. This is 8, a to the power of 5, b to the power of 3, and c to the power of 4. Divide by 2ab c to the exponent of 4. Then, and since we are left with division, we can now use division law for every expression which has the same base. I believe you're following. So it means this will be the root of And by the way, 2 into 2 goes once, and 2 into 18 goes 9 times. So it means here we have 9. Now for A, the base are the same. What do? We take one base and we subtract the exponent. So it's 5 minus 1 times the base for B also. Take one base and subtract 3 minus 1. Same for C. C, it's 4 minus 4. And this will give us the root of 9, A to the exponent of 4, B to the exponent of 2, and C to the exponent of 0. And we know any number at the power of 0 is just 1. So it means this will remain with 9, A to the exponent of 4, B to the power of 2. Then we change, we get rid of the radical sign. This will be 9 A's to the power of 4, B to the power of 2, everything to the power of half. And since we have this, we can multiply in by half all over. But remember, 9 is the same as 3 squared. So if we multiply it by half, it will be 3 squared times half times A to the power of 4 multiplied by half times B to the power of 2 multiplied by half. And what is 2 multiplied by half? Is just 1. It's just 1. So it's 3 to the power of 1. And what is 4 multiplied by half? Is just 2. Then this one gives us 1. So what is the final answer? 3A squared B. It's the answer. So what I've done is, to avoid changing the radical sign, we must first simplify whatever is inside. So look what we used there. We actually used the multiplication law. We used the multiplication law, which is law 1. When simplifying the numerator, we use multiplication law. But yes, looking at A, looking at B's, looking at C. Then we use division law here, looking at the base that are actually the same. Then from there, we simplify it. And we have seen that any number raised to the power of 0 becomes 1. I know, I'm saying we know that. Okay? This is very important for all the grades, especially grade 10 to 12. You need to know this. You need to know how to deal with exponents and surds. Exponents and surds are very important. General grade 10, yes, and 11. Okay, then now we have a surd here. It says find the value of each of the following surd expression. Find the value of each of the following surd expression, writing the final answer in its simplest form. It means without using any calculator, we do not have to write the answer in decimals. So how are we going to do this? We're going to say, okay, we know that in terms of surd, the square root of A times B is the square root of A alone times the square root of B. Now, let's look here. Here we have 7 times the root of 5. Here we have a root of 45, and here we have the root of 20. Let's look inside the radicals, or the root sign. What are the values inside this radical? Here we have 5, here we have 45, here we have 20. Which one is the smallest number then? Smallest number is 5. It means if we try to expand 45 to have 5 inside. And what is 45? 45 is the same as 9 times 5. And what is 20? 20 is the same as 4 times 5. So it means to simplify this, we're going to say, okay, we have 7 root 5, we leave this, minus, we expand 45 to have 5 inside. So it's 9 times 5. Because 9 times 5 is 45. Divide by the root of 20. 20 is the same as 4 times 5. And we know that since we have the root of A times B is the same as the root of A times the root of B, we can still expand this and say, okay, fine. This is the same as it is the same as 7. We're not using a calculator. 7 root 5 minus, we expand this is root 9 by root 5 divided by root 4 times root 5. So we used this law, this one. And this will give us 7 root 5. What is root 9? Root 9 is the same as 3. Why? Because 3 times 3 is 9, which means the square root of 9 will be 3. So this will be 3. Root 5 will give us decimal, so we leave it as root 5 over. What is root 4? Root 4 is 2. So it will be 2 multiplied by root 5. And we're going to group like terms. 7 root 5 subtract 3. So it means from root 5, there are 7, we subtract 3. So we're going to remain with 4. This will be 4 root 5. Divide by 2 root 5. And since in between there is multiplication, it means we can divide the terms that are the same here. So it means root 5 and root 5 will divide. And 4 divided by 2 gives us 2 as the answer. So the answer becomes 2. I hope you guys are following. Without using a calculator, the answer is 2. Then here it's an activity that you can do, guys. It's an activity that you can do. You can go through this activity. 1.1, it's almost the same as the one that I just addressed now. So you can try to solve it and check if you're getting the answers correct. So with this one, if you solve your equation, you must get 1 over 3 as the answer. I want you to try it. You must get 1 over 3 as the answer. If you're not going to get 1 over, without using a calculator, guys, you must get 1 over 3 as the answer. If it's not 1 over 3, something's wrong. Right? Let us look on this one. It says simplify the following expression without the use of a calculator, but we're only going to do 1.1.1. I want us to look at 1.1.2 actually. So let me copy the question here. It says a times b to the exponent minus 1 minus a to the exponent minus 1 times b divided by b to the exponent minus 1 minus a to the exponent minus 1. Remember, we need to simplify this without using a calculator. But look at these guys. First of all, we're dealing with negative, there are negative exponents here. And how do you resolve expressions that have negative exponent? I think I've said that. Remember, b to the exponent minus 1 is the same as 1 over b, right? And a to the exponent minus 1 is the same as 1 over a, which means let's change this. Remember, this is not going to change. So this will be a divided by b. I hope you understand what I've done here. Why is it like this? Because remember, there's a, then we change this. This is 1 over b. And you see it's over 1. So we multiply a times 1 is just a. And b times 1 is just b. I hope you are following. Minus. Same applies with this. This one. This will be b over a. The first one. Why? Because look, we have a to the exponent minus 1 multiplied by b. It means the b will not change. What will change? This one will be 1 over a, but still there is multiplication by b. So it's over 1. So you see that 1 times b is just b, and 1 times a is just a. So we divide everything by, we do the same this side. This guy here, this will be 1 over b, and there, this will be 1 over a. So to avoid writing, like we need to simplify these fractions here. And guys, to simplify the fractions here, what we're gonna do, we're gonna simplify. Let's just simplify the fraction. I think I've explained to you how to simplify fractions. Let's start with the one at the numerator, actually. We start with the one at the numerator. At the numerator, we simplify the first one. These are two fractions. So what did I say? You multiply the denominators. So let's multiply the denominators. So this will give us, okay, one division sign. Multiplying b with a. B times a is the same as ab, so it's ab. Then after that, we cross multiply here. We start with this side. A times a, exponent, guys, it's a squared, minus b times b, it's b squared. So we have simplified the first expression. Then we do the same in the second one. We multiply the denominator, b times a, it's ab. Then we do the same because multiply 1 times a, it's a, minus b times 1, it's b. So what do we have? We have a squared minus b squared divided by ab. And we're dividing this with a minus b divided by ab. I believe you understand what I've done. I changed this division to be that. And we know in terms of fractions, if you are dealing with divisions, let's say you have a over b, you are dividing this with b over c. We can change division to multiplication by not changing the first one. So it's a over b multiplied by c over b. Okay, so it means this is the same as a squared minus b squared over ab. So now I can change division to multiplication, and to do that means this one I have to make the reciprocal of this. This will be ab over a minus b. So we know in terms of multiplication, whenever there is a multiplication, then we are allowed to divide terms that are the same. Or if you are not dividing, then we can do this. We can multiply the numerator together, and we also multiply the denominators together if we do not want to multiply, divide, because actually, because there's multiplication here, this and this can divide. So it means we're going to remain with, at the numerator, a squared minus b squared. This side we're going to remain with a minus b. But this is a difference between two squares, this one. So a squared minus b squared is the difference between, which is factorizable. We can factorize it as factors of a squared, it's a and a. Of b squared is b and b, with different sign, minus and plus. So it means this will give us a minus b into a plus b divided by a minus b. But this one is relevant for grade 11, not grade 10, guys. So we divide this, then the final answer will give us a plus b. So it's testing us on how to change simplifying expressions that have negative exponents. Then the last one is this one. That says, if given that 7 to the exponent of x is 5. So they told us that where there is 7 to the exponent of 5, 7 to the exponent of 5, fx is 5. Then evaluate the expression this without using, want to know this. Okay, what do we have? This is the same as 21 to the exponent of x divided by 3 to the exponent of x plus 3 to the exponent of x. Now we have to expand this. 21 is the same as 3 times 7. So it means this is the same as 3 multiplied by 7 to the exponent of x divided by, look at this. We have 3 to the exponent of x plus 3 to the exponent. So you cannot use multiplication law here. Here we're just adding like times 3 to the exponent of x plus 3 to the exponent of x is just 2 times 3 to the exponent of x. Now we can expand this inside because we know a times b to the power of n, it's a to the power of n, b to the power of n, right? So it means this will be 3 to the exponent of x times 7 to the exponent of x divided by 2 times 3 to the exponent of x. You see that since we have multiplication in between, then we're allowed to divide terms that are actually the same at the numerator and denominator. So it means 3 to the exponent of x will divide 3 to the exponent of x. So what are we going to remain with? We are remain with, at the numerator, remain with 7 to the power of x. Denominator by 5 by 2. But already they told us that 7 to the power of x is 5. So it means the numerical value is 5 over 2. I strongly believe you understand, guys. This is how we deal with exponent. This is how we actually deal with exponent. So this is the end of the session, guys. Kindly like the video, subscribe, and also share with your friends. Remember, practice makes perfect. Thank you very much. Bye-bye.